What are gases? Well, before we get into what gases are, we're going to talk about some important gases. One case is oxygen. Oxygen is important because this is what we breathe. Carbon dioxide is an important gas because it is involved in photosynthesis, which relates to oxygen in the atmosphere. Methane is an important gas because it's one of our greenhouse gases that keeps the planet warm. O3 is ozone. It's an important gas because it protects us from UV radiation. Water is important because as a vapor it condenses and turns into rain, and it's also considered a greenhouse gas. Nitrogen makes up 78% of our atmosphere, and it's important because we use it to make our proteins as well as our DNA. So what are gases? It's a state of matter where particles move freely and fast. Gases are mostly invisible, some have odor, and some don't. There's a lot of free space in between gas molecules, which allows them to expand and be compressed. Gases occupy containers in a uniform fashion and are completely filled. And gases also diffuse and mix rapidly. Gas particles are very, very tiny in comparison to how far apart they are. So their relative size compared to how far apart is huge. They're in constant and random motion, and when they collide with each other, they do not lose kinetic energy, and therefore they just bounce off in an elastic fashion. The average kinetic energy depends on temperature. So as temperature rises, that means that the molecules in the gas are moving quicker. Terms to know. Gases are related to units of temperature, pressure, volume, and moles. So what is temperature? Temperature is a measure of kinetic energy. In other words, how fast these molecules are moving. In gases, when the kinetic energy is high, this means that gases are moving really fast. The units that we use are Kelvin. The Kelvin scale goes from 0 Kelvin, which is called absolute zero, all the way up to an unknown value. In order to solve for Kelvin, we use this equation, K equals degrees Celsius plus 273. The reason why we use Kelvin is because there's no negative values. In order to measure temperature, we use an instrument called a thermometer. Pressure. Pressure is a force applied over a certain area. Pressure relates to how much force is applied to the walls of the holding container by the gas. Atmospheric pressure results from the mass of the air being pulled toward the center of the earth by gravity. High pressure relates to a lot of force. The units that we use when we're dealing with pressure are atmospheres, torr, pascals, kilopascals, millimeters of mercury, and PSI, which stands for pounds per square inch. In order to measure pressure, we use an instrument called a barometer. A barometer looks like this, where as the air pressure changes, the volume inside this vacuum chamber also increases or decreases. As the increased air pressure changes, so does the volume in the vacuum. It also changes by increasing. In order to convert in between different pressure units, one standard atmosphere equals the following: 760 millimeters of mercury, 760 torr, 101,325 pascals, 101.325 kilopascals, and 14.69 pounds per square inch. Standard temperature and pressure relates to a temperature value of 0 degrees Celsius or 273 Kelvin and a pressure at 1 atmosphere. This standard temperature and pressure is used to make comparisons between gases. So let's get some practice in convert between pressure units. So if we have a height of mercury and a mercury barometer measured to be 732 millimeters of mercury, represent this in atmospheres. Represent it in torr, represent it in pascals, and represent it in kilopascals. If you use your conversion factors, you should get the following answers: 0.96 atmospheres, 732 torr, 97,600 pascals, and 97.6 kilopascals. More practice. So if the pressure of a gas is measured to be 2.79 times 10 to the 5th pascals, represent that in pressure units of atmosphere, torr, and pounds per square inch. When you do so and you use the correct conversion factors, you should get 2.72 atmospheres, 2,070 torr, and about 40 pounds per square inch. So what is volume? Volume is the amount of space taken up by gas, and it relates to the size of the container. It has units of liters. It also has units of milliliters, where 1 liter is equivalent to 1,000 liters. Last unit that we're going to talk about are moles, and moles represents how much gas is present. It relates to concentration, and their units is mole.